record. So now I'm recording. This is the second day of 3-2, and we will finish this today. So I just taught it to F period. Now we're in G period. This should be a really, I want to go slowly through this, but there's some calculator stuff, which is why I've got my calculator on the screen and my normal notes up. We skipped 3 and 4 the other day, and I'm going to keep 3 and 4 skipped. If I really decide I want you to do it, I'll make a video and put it on YouTube, but it's similar to ones we've done in the past, and I want to do new problems today. So I'm going to briefly go over number 5 because that's the one that we ended on last class on Friday. And I know that there's been some time between now and then, and I know I rushed through it, so I want to review it. We're going to do 2 problems like it today, so if you still have questions, we'll work through it, and I hope that will make more sense. So number 5 has an initial value, a limit to growth, and it contains a point. And I told you it's a logistic function. So what I have in like the pink box right up here is the general equation for a logistic function. So C, the number in the numerator, is always your limit to growth. It's like your upper horizontal asymptote that we never cross. We get closer and closer to, we will never cross it. Your initial value helps you find your A. So I needed to write my initial value as 0, 10. The initial value is always a Y value. It's your first Y. So it's where X is 0. I plugged 10 in for Y, I plugged 0 in for X, and then I was able to cross multiply 1 plus A on both sides, divide, minus, and I got A equals 3. Once I got A equals 3, I'm using a new X, a new Y, and then this A in order to find B. I still have C 40 in as well. This time my new X and Y are 1 and 20. So I used 3 for my A. I plugged 1 in for X and 20 in for Y. Cross multiplied 1 plus 3B on both sides, divided by 20 minus 1 divided by 3, and I got B equals 1/3. The only other new thing I did is I put it all in one equation, so I don't remember if we did that together or not, but the only thing I did was combine it. I put my A and my B in my equation with my C. So Y equals 40 over 1 plus 3 times 1/3 to the X. So that's my logistic function in that highlighted yellow. We're gonna do another one just like it. 2 more just like it actually. This one is written the exact same way. We're just gonna plug in and practice that. I'm still using my general formula that's here. My C in this new problem is 128. We're gonna start with the initial value and then we'll make our way over to the other X and Y. This is a little funkier of an answer. So I did kind of a clean answer. Now we're doing kind of a weird one. My initial value, we can think of this as 0, 16. So I have 0 as my X. Y equals 128 over 1 plus A times B to the X. X is going to be 0. Y is going to be 16 because I'm using my initial point. The whole reason that's helpful is the B to the 0 is 1. 1 times A is still A. So I've got 16 equals 128 over 1 plus A. I like to cross multiply, so I've got 16 times 1 plus A equals 126, which leaves me a really easy place to divide by 16. So I've got 1 plus A equals, I believe it's 8. Yes, 8. 128 divided by 16 is 8. And then we just minus 1. Oh, I've got a nice easy A, 7. I'm going to use this A, I'm going to use my C, and I'm going to use my new XY value in order to find B. So I still have Y equals 128 over 1 plus. Instead of A, I'm going to write 7. And then B raised to the X. Instead of X and Y, I'm going to use 5 and 32. I can't do any simplifying. I can't add 1 and 7 because 7 is being multiplied by B. So I'm going to cross multiply. I've got 32 times 1 plus 7B to the 5th equals 128. Divide by 32. 1 plus 7B to the 5th equals 4. Okay, minus 1, minus 1. 7b to the 5th equals 3. We can't do anything with that 5 until we get b by itself, so we're going to divide by 7. I already previewed that this was going to be kind of funky. We're going to 5th root it. So whatever power we do, we're doing that square root. So since I've got a 5th power, I'm 5th rooting. So b equals the 5th root of 3 over 7. That's so ugly. I don't need us to rationalize that denominator. It's going to be fine. While a was an easy, nice, pretty number, b was a little weird, but we can still write this in one big equation like we did on the last one. So I'm going to go off to the side and write y equals 128 divided by 1 plus 7 times the 5th root of 3 over 7 raised to the x. So I'm going to go write that over here all together. So my logistic function altogether, y equals 128 over 1 plus 7 times my 5th root of 3/7 raised to the x. Any questions so far? Am I moving too fast? I'm just going to chug coffee while I wait for you guys to finish that. Okay, the next problem is super similar. It's just not handwritten out in that format, but it's got the same concept. I still have, this time it's a graph, it's a logistic graph, and I've got 3 things labeled. I've got the point 0.5, which is right there. I've got another point called 210, and then I have y equals 20. That's my horizontal asymptote. Well, 20, that's the same thing as my c. That's my limit to growth. I'm not going above 20, so that's my c. That's my limit to growth. My 0.5 is my initial value. I know gray is a pretty sucky color to write. I'll pick a different one in a second. And then 2 and 10 is just a random x, y. So I have exactly what was given to me before. It's just drawn in a picture, not handwritten out. So we're going to use these. We're going to start with our C and our initial, and we're going to find A. So I've got y equals 20 over 1 plus A times B to the x. Again, I write y and x just to, prove a point, but you can go immediately and write 5 equals and then put 0 in for your x. It does not matter to me. Again, I know this is logistic because this is what the logistic parent function looks like. So the logistic parent function's at S, and it's bounded by 2 horizontal asymptotes. So that's how I know that I'm here. B to the 0 is 1, so I've got 5 equals 20 over x plus A. Let's distribute that 1 plus A to both sides. Divide by 5. The heater's like shaking in here, it's making weird noises. 1 plus A equals 4 minus 1, A equals 3. Any questions so far? Okay, that's my A. Now we're going to use the other point to find B. So you can go immediately to do 10 equals 20 over 1 plus, instead of A, we're going to write 3. B, and then my exponent here, my x is 2, b squared. I think I just mentioned this, but I want to say it again with purpose. You don't get to add the 1 and the 3. A lot of people want to add that to make that 4. You don't get to do that because 3 is being multiplied by b squared, and so I can't combine these because they're not like terms. That's just a common mistake I see. I just want to bring that up. Now that I kind of touched on it, I want to really force myself on that. Okay, cross multiply 10 times 1 plus 3b squared equals 20. Divide by 10. 1 plus 3b squared equals 2. This will be a little funny, but not as bad as the last answer. 3b squared equals 1. Divide by 3. b squared equals 1/3. So I got to square root both sides. You can write a 2 in your radical, but that's redundant. It's like the same thing as writing 1a. Like maybe when we were in algebra 1, we wanted to write 1x or 1a, but now we know we don't have to. Same thing here. You can write a 2 there, but it's implied if it's a square root. So b equals radical 1/3. And this, for the sake of today, we can just leave it there. For the sake of what I will ask you on this quiz, you won't have to rationalize any radicals in a problem like this. So just leave it like that. Altogether, it's y equals 20 over 1 plus 3 times root 1/3 raised to the x. Okay. So that's the third example of those types of problems that we've done. Any questions so far?
Can you zoom out so I can see the other part of that graph, please?
Yes. I'll leave it here for a minute. The next 5, I think, are word problems, and we do use our calculator. So if you have a calculator, I would get it so you can walk through this with me. If not, I'll have it on my screen too for you to look at. All right, are we good to move to the next one? Anyone need me to slow down? Okay. The next 2 problems actually give us the equation, so that's going to be helpful. And then the 3 after that, we're going to have to write the equations. There's some plug-in in here, and then there's also some graphing. So that's why I've got my calculator up on the side. Number 6 is talking about the spread of flu. That hits a little too close to home. Just replace flu with COVID, and that feels very relevant. And it's at this high school called Springfield High School. And it gives us this model, which is the number of students that are infected by the flu after T days. So first thing we want to do is find the initial number of infected students. So the initial number of infected students happens on day 0, so when time is 0. We're going to plug 0 in for T, and that's going to tell me what my population at 0 days is. So how many kids came to school, or how many kids had the flu day 0 before we even started counting. So I'm going to come over here. I like to write P of 0 because I think that's the best mathematical expression. It's a function, the population in terms of time. P of 0 would be population at 0 days. If you want to just write Y or not write it at all, that's also okay. I've got 800 over 1 plus 49e to the negative 0.2 times 0. Well, this is good because anything times 0 is 0. So I've got 0 on top, 0 in my exponent, and then e raised to 0 is 1. So that goes away. That gives me 800 over 50. 1 plus 49 is 50. And then 800 divided by 50 is 16. So that means on day 0 of the flu being in the school, we already had 16 students who were infected. So I knew to plug in for T because it says what's the initial number of infected students. My P of T is in terms of students. My T is in terms of time. So the next 2 questions are when questions. So it says, when will the number of infected students be 200? The school will close when 300 of the 800 student body are infected. When will the school close? So if I'm asking when, I don't know what T is. So I'm finding out what T is in both of these. T is currently a question mark for both part B and part C. But what I do know in both of them is what my population is, or how many students are sick. So in letter B, we want to know what day or what my T is when my number of infection is 200. Instead of plugging that in for T, I'm plugging that in for like my Y or my P of T. So I'm going to say 200 is equal to 800 over 1 plus 49 e to the negative 0.2 t. Negative 0.2. That's important. Now, you maybe learned how to solve that, and we could definitely simplify it algebraically, but I haven't taught you log rolls or how to solve for that exponent yet. That's hopefully what I teach you tomorrow. And so since I haven't done that yet, we haven't done the logs and the exponentials together, we are gonna just graph to find out what t is. Now, before I go to my calculator, I am gonna write the other one. C is very similar. It's just instead of 200, I'm gonna say 300. So it's 300 equals the whole equation. Both of those, we're gonna find out what t equals. So I'm gonna say t equals whatever. That's what I'm about to find in both of these. But in order to do that, I have to plug them into the calculator. So I'm just setting up my equation for success for both of these. I'm gonna pull my calculator up and I'm gonna put these in my X1 and Y1. I'm gonna do my horizontal line in my Y2 and I'll put the actual equation in Y1. So I've got 800 divided by, I put everything in parentheses to keep it all together. Second ln is e to a power negative 0.2x. Make sure to close your parentheses. I don't know what's going on with mine when they aren't closed. This calculator that I'm using on the computer is like a newer one, so I don't have to put parentheses around my exponent, but I used like my old one this morning when I was checking my work, and I had to put parentheses around everything. So make sure you have adequate parentheses, especially if your graph doesn't look like mine. Now windows, that's the hardest part. I don't know what my X-min and X-max are always gonna be 0, because if I'm talking about real life situation, I'm not gonna have negative 20 students or in negative 20 days. That doesn't make sense. So my mins are always 0. My max, I'm really not sure. I'm gonna maybe plug in like 10 and see if that works. If I need to go bigger, I will. My Y max though, I need to at least get to like the 200, 300. So I'm probably gonna put like 500. Also think about my limit to growth. The numerator is 800. So the very top of my graph goes to 800. So I also could do that. I could just go to the very top of my graph and find out from there. But I at least need to be more than 200 or 300. Let's graph that and see. Okay, not enough on my X's. I need to go bigger on my X's. So let's make my X's like, I don't know, 30. There we go. Ooh, I see a nice pretty graph. It looks like a logistic graph, and then I've got a point of intersection. Almost all of what we're doing today is finding point of intersection. So I'm not gonna talk through it except for this first time. Second, trace 5 is intersect. Get on one curve, it looks like I'm on blue, good. Second curve red, also good. Guess anywhere is fine. Cool, they intersect at 13.97. I'm gonna round that up to 14. So 14 days is when we hit our 200th kid. Questions so far? I'm gonna do the exact same thing, but I'm gonna go change that 200 to 300. I think my window is gonna be okay. I'm gonna keep my window where it's at, but all I'm gonna do is, for problem C, I'm just gonna change this to 300 instead of 200. Okay, graph. Awesome, new point of intersection, find it. This intersects at 16.9. Again, I'm gonna round that up. So 16.9, I'll make that 17 days. So after 17 days, we had to close down the school because too many kids had the flu. Any questions on that problem? This is a similar process for the other ones that we're doing. So if you're good with writing an equation and then graphing to find the intercept, you're gonna be awesome at this. The next problem is not maybe as relevant, but that's probably good. It's about deer. I don't even know the last time I saw a deer. I have to think on that one. Population of deer after T years in Cedar State Park is modeled by this function. Oh, cool, they gave us a function again, that's awesome. What's the initial population of deer? Oh, we just did initial population a second ago. T equals 0. Plug and chug. We're gonna go find that. Letter A is when t is 0. So it goes 1001 over 1 plus 90 e to the negative 0.2. And instead of t, I get to write 0. Just making sure I had that right. 0 is my exponent, which is awesome. That all becomes 0. E being raised to 0 is 1. So that gives me 1001 over 91. And when you divide those two, you get 11. So we started with 11 deer in my state park. Cool. When will my population be 600? Again, it says when, which means I don't know what my t is, which means that 600 is that p of t. Stop. It's my y. So I'm going to plug this in for my y, and I don't know what my t is. I don't know my when, so we're going to find t. We're going to do this exactly like we just did b and c on the last problem. So letter b, I'm going to say 600 instead of p of t. I'm going to write the rest of my equation the same. I'll zoom out in 1 second. I do not have t this time, so I need to make sure I use my x as my t. So let's plug it in. Again, my y2 is going to be like that horizontal line that I'm finding the intersection at, so that's going to be 600. And then I'm just going to completely clear this out. I don't want to just fill in numbers in case it doesn't fill nicely. I'm going to do 1001 divided by, put the whole denominator in parentheses. I know you're probably like, oh, I know how to plug into the calculator. I really would challenge you, especially before we quiz, to practice plugging it into the calculator, because there's nothing worse than being like, okay, I know what Miss White did. I know I could do it. But if you don't actually go through the motions and see, okay, where do I need parentheses? Where do I not? How do I find a window? How do I not? It's going to be a lot harder to do on the fly in a timed quiz situation. So please, please, please practice this before you take a quiz, or just so you know what you're doing. I have my equation. I have my line where I'm going to intersect. Technically, if I wanted to see the top of this graph, I would need to get to at least 1001. So if we wanted to make my window 1000, we could. It should be fine at 800. So I'm just going to leave it at 800. I have no idea what my x is going to be. I don't think 30 is a bad guess. I should be able to see if it's less, and then if it's more, I can always make my graph bigger. So I'm going to leave it at 30. Oh, and I lucked out. I can see it. Awesome. Find your intersection. $24.5. So I'm going to round that up to 25. So that's 25 years. After 25 years, my deer population should be 600. And then letter C, we don't even need the calculator for. It says, what's the maximum number of deer possible? We've done a lot with logistic functions, and we keep talking about this limit to growth, the ceiling that I'm never going to get higher than. When I have whatever's in the numerator is that ceiling to growth. That's my limit to growth. It's the ceiling I can't go above. That's my maximum number of deer. So by just knowing what I know about logistic functions, I know that the maximum number of deer is 1001. I'm just going to write that. And I'm going to remind myself it's the limit to growth in case I don't remember how I knew that when I go back to look at my notes. Limit to growth. Okay, so those were the two problems where they gave us the equation. The next few, we need to write our own equation. Does anyone have any questions before I move on? We're going to do some more graphing, but these were logistic functions. The next three problems we're doing are exponential functions. So we're going to have an exponential graph, not a logistic graph. It won't look like an S anymore. Okay. Number 8 says the population of Smallville in the year 1890 was 6,250. Assume the population increased at a rate of 2.75% every year. Okay, we have to remember the function we learned like on Friday. I know a lot has happened between now and Friday, so let me remind you what it is. It went p sub t equals p sub 0, 1 plus r raised to the t. Let's talk about what this means. P sub 0 is my initial population, my starting value. It's your initial, what you start with. Your R is your rate in percentages, usually. And then the plus, it could be a minus depending on if we're increasing or we're decreasing. So we have to read our words to decide if the rate is positive or if the rate's negative. And then T is just your time. However, if we have something that doesn't happen every year, maybe it happens every 2 years or every 20 days, we do something to that T. So T is normally like untouched, but sometimes we do something to it in order to account for it not happening every day and happening only every few days. So this is just a reminder. We looked at that formula last week, but we need to use it today. So it says in 1890, my initial population was 6,250. So that goes for my P sub 0. I'm gonna write 6,250. And then it's increasing at a rate of 2.75%. So I'm gonna do 1 plus 2.75%. Remember to make that a decimal by going 1, 2 places. Fill that spot with a 0. So 1 plus 0.0275 and then raised to the T. It happens every year. Nothing funny is happening to the T. The only way I can simplify this is by adding the 1 in the rate. So I've got 6,250 and then 1.0275 T. It didn't specifically ask you to write your equation, I just did, but I'm gonna use that because it says estimate the population in 1950, 15, and in 1940. Well, I didn't start in 1900, I started in 1890. So we need to add, we need to just see the difference between them. You're welcome to do like a little minus problem off to the side, 1915 minus 1890, or you can just think in terms of years. So I know from like 1890 to 900 is 10 years. And then from 900 to 1950 is 15 years. So I'm looking at T equals 25. Similarly, from 1890, I keep getting those mixed up. From 1890 to 1940, that's 50 years. So I'm plugging in 50 and 25 into this equation to see what I get. Got to zoom in a little bit so my writing's not so trash. So I'm going to do P of 25 equals 6,250, 1.0275 raised to the 25th. I was just dramatic with my colors to show you that nothing changes except we plug 25 in. And we're going to find out what that answer is in a second. And I'm going to do the exact same thing with my 50. Literally nothing changes except I plug 50 in for my exponent. The P of 25 and P of 50 is just correct notation for a function. I believe in using correct notation as much as possible. I wouldn't mark you off for it, but I'm going to show it always. So we plug these guys in. You can plug them in straight across if you want. Oh, nice. I already have them plugged in, so I'm not going to redo them. I plug them in straight across. If you'd rather, sometimes when I do this by myself, I do it one at a time. I do like 1.0275 raised to the 25th, and then I multiply that, and then I multiply that by my 6,250. You'll get the same thing. This is the first one. But if you want less steps, you can write it all out together. So when I plugged in 25, I got 12,314.75. Let's make that 15 people. And then when I plugged in 50, I got 24,000, sorry, numbers are hard today. 24,265 people. So that's what I got when I plugged in 25 and 50. Okay, just a plug and chug. The next one we do have to use our calculator for to graph and find an intersect. So let's do that. Predict when the population will reach 50,000. Predict when. I don't know when. I want to know when. I want to know t, but I don't know it. So this is my y, or my population. So I'm looking at 50,000 is equal to my equation, 6,250, 1.0275 raised to the t. This is just an exponential function, which I think is a little easier than a logistic one, but we're doing what we just did a couple times above with my logistic functions. I'm going to plug this into one of my y's, and I'm going to plug this into my other y. Any questions on my equation? Okay, let's plug it in. Instead of 600, I'm going to write 50,000. 50, 3 zeros, okay. And then I'm going to write 6250 times 1.0275 caret x raised to the x. Now, my y here, I already need to get to 50,000 in order to find where they intersect, where they cross. So I need to go a little bit above 50,000. I'm probably going to go 70,000, 80,000, 70, 1, 2, 3. And then I really have no idea what the year should be, so I'm going to keep it at 30. That should give me enough space to see if I need to go bigger or if I can go smaller, but let's check it out. Okay, it's increasing really slowly. I've got a lot of ways to go. I'm probably going to bump that 30 up to 100, so I don't have to do this 20 more times. So I'm making my x a little bit bigger from 30 to 100, so hopefully I can see more of the graph. Ooh, perfect. I see it right there. Let's find their intersections. Good. My intersection's at 76.65, which is about 77 years. T equals 77 years. So that's a good enough when, like in 77 years this happens, but we could also find out exactly what year it happens because I know that I started at 1890. So we can just do 1890 plus 77 and that will tell me exactly what year we got this in. So 1890 plus 77. And that gives me 1967. So in the year 1967, my population of Smallville will be 50 million, or 50,000. Any questions so far? All right, let's do another one like it. Practice makes us better. This one now is talking about Jacksonville. So the 2000 population, the population in 2000, the year 2000 of Jacksonville was 736,000, and it was increasing at a rate of 1.49. And then it wants me to know when will the population be 1 million. So we actually only have one step on this problem, which is great. We're using the same formula, so if we need to like copy and paste it, we can do that. No, need that G, I don't know why he came with. My initial population is at 736,000, I'm so sorry. Number, and then it's increasing 1 plus 1.49. Well, let's make that 1 plus 0.49 a real decimal. So I've got 0.0149 and then raised to the T. When I go to plug this in my calculator, I'm just going to simplify what's in parentheses to be 1.0149 raised to the T. And then instead of my piece of T, I'm going to write my 1 million. So that's 1 comma 1 2 3 zeros, 1 2 3 zeros, a total of 6 zeros. Again, we're just going to graph. One of them goes in one Y, one goes in the other Y. This is going to be really big because I have to get to 1 million. So I'm going to need I'm going to have to change my window at some point. Instead of 50,000, I need 1 million. 1, 1, 2, 3, 1, 2, 3. And then my equation, 736, 1, 2, 3 zeros times 1.0149 caret x. Biggest thing is don't lose track of a zero, don't lose track of a decimal. Just be really careful, really cautious as you plug these in. Really easy to make a mistake if you don't have enough zeros. I have no idea what my x min or x max is going to be. I'm going to keep it 100, but I am going to make my y max to be bigger than 1 million. So I'm probably going to do 1,200,000. So I've got 12 and then 5 zeros. And then I have no idea if 100 is too big or too small, but we're going to keep it and we're just going to see what happens. Graph. Oh, it looks like it was pretty big. I didn't need to go that big, but I can clearly see my intersect, so I'm not going to change my window. It's fine. We'll second trace. We'll do intersect. And so that gives it to me at 20.7, which is 21. So we'll say t equals 21 years. So based on this model, in the year 2021, which would be this upcoming year, the population of Jacksonville, Florida should be 1 million. I bet this problem is from like an old book, so 2021 probably felt so far away when this problem was written. Okay. We got one more problem. Any questions before we get started on this last problem? Okay. This one says half-life, and the minute we read half-life, some of us just shut down. We're like, I don't want to do this. Half-life is not that hard. Half-life just means that in the amount of time that it is the half-life, so in 65 days, we lose half of what we have. So if I had 10, in 65 days, I'm down to 5. So the half-life means I'm decreasing by 50%. Some teachers teach it a certain way and some students remember it a certain way, but I don't like to just memorize dumb stuff if I can reason my way through it because I'm afraid of forgetting it. So what I would probably think of is I'm like, okay, well, my rate is 50%. So I'm going to do 1 minus 50% as a decimal, 0.5 or 1/2. Some teachers teach you to go directly to just 1/2 as half-life, but I can't always remember that, so I like to reason my way there. You get there either way. I start with 3.5 grams, so that goes for my P sub 0. I've got P of T as my function on the left side. And then this is where we're going to have to do something funny to my T. The half-life doesn't happen every year or every day. It happens every 65 days. So in order to represent that, I'm going to do T divided by 65. The reason is, or the reason we do it this way, is because I need T to equal 65 before I lose half of my materials. So in order to represent that, I can't do my full half-life until T is equal to 65, which means that I'm doing my 1/2 raised to the 1. So I'm doing 1/2 of that 3.5. So in order to lose half of it, I have to get to a full 65 days. So in order to represent that, I divide by 65. You can remember by knowing that in half-life, we always just divide by whatever the amount of time is in the half-life, or you can reason your way through it just like I did. We wrote my equation. Oh, that's actually part A. Perfect. Already done. Part B says, when will there be less than 1 gram remaining? Okay, that means I'm using my whole formula on the right side. You can make this 0.5 or 1/2, T to the divide by 65. And then I want to know when it's going to be less than 1. So 1 is greater than my equation. We'll talk about what that inequality looks like when we look at the graph, but let's graph this. We just did a super big one. Now we're going to do a really small window because my Y2 is at 1. It's not at 1 million, it's at 1. 3.5 times 0.5 raised to the, if you don't have your calculator up like this so you can physically see that it's x divided by 65 on top, I'd put parentheses around your exponent. Mine just goes on top. I visibly see that that's what I want it to look like, so I'm okay. My window, for my Y's, I don't want to be any bigger than like 5, because if I have my line at 1, I want to be able to see it. So I'm going to go 5. You could even do 2 or 3 if you want, but I at least need to see 1 in my X or my Y mins and max. For my X, I'm not really sure. I'm going to keep it at this 100 and we'll see if we can see it. If not, we'll make it bigger. But we're going to have to go a little bit bigger. I'm getting really close to it, but I'm not there yet. Let's make it like, I don't know, 150. Perfect. Now I can see my intersection. I see it. I'm going to go find it. My intersection is at 117.47, so I'm going to round that to 118. And so I'm going to say, after this many days, we are less than 1 gram. Because after that, it keeps getting smaller and smaller. So it equals it at 118, but after that, it gets smaller and smaller. So after 118 days, we are where we want to be. All right, we ended perfect time. Does anyone have any questions while I've got my screen still up? Okay, I'm gonna stop my share and stop the record.